In this chapter, we have discussed types of forces, net force, free body diagram, and pressure. Lesson is finished. Now we have some questions after the lesson. We shall have a discussion of these questions. Okay. The first question: what is force? What changes can be produced by a force? So students, those who are watching these videos continuously, part by part, they are able to answer this question very easily. Okay. So how force result? Simple. Once again I repeat. Okay. If I want to remove the cap of this marker with my hand, I am going to pull this, right? Yes or no? So here two bodies are interacting, marker and my fingers. When two bodies interacts, force results. That interaction either push or pull. All actions they have divided into only two categories, either push or pull. That is why the push and pull of an object is called force. Force results due to the interaction between the two objects. What changes can be produced by a force? Okay, a net force can change the direction of the body. Okay, whenever football player ball comes towards him, he changes the direction. Okay, goalkeeper, right? A bowler when bowls the ball, can the batsman allow the ball to hit the wickets? No, he will hit the ball. Ball direction changes, right? See, force can change the direction of the motion of the object, and also force can change the shape of the object also. If you break the small chalk piece, piece of chalk, what happen? Shape changes. If you crush the bottle, shape changes. If you squeeze the sponge, shape changes. Okay, shape changes. We can force can stop the object which is in motion. If you catch the ball, what happen? It comes to rest. If you kick the ball, what happen? The ball which is at rest undergo motion. So force can bring the motion, force can stop the body also. So these are all the effects of net force that we have discussed. Okay, right. Give two examples of each for a contact force and a force at a distance. So what are the examples of contact force we have discussed? First one, muscular force. The force exerted by the muscles is called muscular force. Normal force. The force exerted between two surfaces in contact perpendicular to the surfaces in contact is normal force. Okay. And frictional force. Frictional force which opposes relative motion. Why does the object slows down? When we kick the ball eventually slows down after rolling across the floor certain distance. After covering certain distance, it comes to rest. Okay, here friction opposes the direction. Friction act opposite to the direction of motion. It is a negative force. It doesn't allow that ball to move continuously. It opposing motion, right? Next, and other contact force what we have discussed, tension force. So tension force always act along the string, right? So clear videos we have in detail we have discussed all these things, right? And forces at a distance. There are three forces. Okay, a gravitational force, magnetic force, and electrostatic force. What is the major difference between these forces? Here, contact force means force results due to the two interacting bodies, right? The two interacting bodies physically in contact, then only these forces can exist. But gravitational force, there is no physical contact. If we release this marker falls. This earth, even though there is no physical contact, earth can exert force on the objects. Okay, magnet also, even though there is a separation between two magnets or magnet and magnetic material, they can exert the force. Electrostatic force. Also, when there is a gap, positive charge attract negative charge attract positive charge, positive, negative repel each other. Okay, so these forces exert even though there is no physical contact. That is why they are called forces at a distance. So detailed videos already we uploaded. So part by part, if you go through all those things, you will understand all these things. This is improved learning. We are discussing question answers. Okay. So students, those who are watching the videos continuously, part by part, you are able to answer these questions very easily. Right. Next, explain gravitational force by giving a suitable examples. Okay. So gravitational force means what? The force exerted by Earth, not only Earth, any mass. Moon doesn't exert gravitational force, it exerts. Jupiter doesn't exert gravitational force, it exerts. So every body which has mass, okay, attracts other body which has mass. So the attraction between the two certain masses is called gravitational force. Okay. So rivers flows down into the sea because of gravitational force. There is atmosphere around the earth due to gravitational force. right? Any body projected up eventually falls back due to gravitational force. All these are best examples of the gravitational force, right? Next, draw and explain the free body diagram to show the forces acting on a car. So, already we have discussed this concept in the free body diagrams. Car is at rest, okay? Vertically, gravitational force acts downwards. Here, normal force comes into play when there is a contact between two bodies. Here, tires are in contact with the surface of the road. That is why this road exerts a normal force in upward direction. Okay, this is N1, this is N2. So, two normal forces exert in upward direction. These two normal forces balances the gravitational force. That is why the net force along the y-axis is 0, vertically 0. Now here, when this is at rest, that's all. If this car is in motion, for example, let's say car is moving this way. This is the direction of motion. Here, engine exert force on the car. The force exerted by engine on the car, let's say capital F. But there is a friction coming to play between the tires of the road and tires. That is friction. So every time this friction, to overcome this friction, the engine has to exert the force on the car. So this force and this force, if they are balanced, car goes with uniform motion. If these two forces are not balanced, car goes with non-uniform motion. So detailed video already we have discussed regarding free body diagrams. There we have discussed once. Please go through those videos. Next, why do tools meant for cutting always have sharp edges? So if the edge is sharp, area decreases. Area decreases. When area decreases, pressure is equal to force by area. If you keep the force constant, okay, for the same amount of force applied, when area decreases, pressure increases. To increase the pressure, the tools have sharp edge to increase the pressure. Okay, so tools should have the sharp edge to increase the pressure. Okay, so these are the first bit question answers. Okay, regarding this pressure also we have one video, detailed video. Okay, this is very easy. Okay, easy to answer. These are all the easy questions to answer. Okay, next second bit we are going to discuss, right? So now we are talking about another important questions which are given in the second bit of reflection of concepts. Okay, that we have finished. Now applications of concept. How can you differentiate between a contact force and a forces at a distance? So in contact force, two interacting bodies physically in contact. For example, you are opening the door, your fingers and handle of the door in contact. You want to brush your teeth, right? Whenever you want to brush your teeth, you have to apply the force on the tube of the toothpaste. Then paste come out. Yes or no? You are pressing with fingers, right? Okay. So fingers and toothpaste tube both are interacting bodies. So it is contact force. So force is at a distance. Gravitational force. Any body projected up, there is no contact between them, even though the body falls down due to gravitational force, even though there is no physical contact. So force exerts even though there is no physical contact is called force at a distance. Okay. When there is a physical contact between the two interacting bodies, that is contact force. Now find the net force, right? So here you see, how do we find the net force? We have done many problems. Okay, once again I repeat. See here, these two forces act in the same direction. When two forces act in the same direction, we have to add those two forces. Okay, what is net force? It is algebraic sum of all the forces acting on a body. Here three forces acting on a body according to diagram. We have to add all the forces. Okay, now I am going to add 8 Newton plus 10 Newton. I am going to calculate net force. Okay, 8 Newton plus 10 Newton. It is acting towards the right side. But 12 Newtons act towards left side. Plus 12 Newtons. But minus sign should be taken before 12 Newtons. Why the minus sign should be taken? What is the reason? The reason is this force act opposite to the first two forces. Whenever two forces act in the opposite direction, the sign to be taken negative. Okay, but technically the net force is the algebraic sum of all the forces. Whenever we do the addition, one of the force is which is working opposite should be taken negative. So plus into minus become automatically minus. So 8 Newton plus 10 Newtons total together it is 80 Newtons plus into minus minus 12 Newtons. The net force is equal to 6 Newtons towards, see, force has a direction. Is this force towards right or left? Towards left or towards right? Towards right. Direction also should be mentioned. Okay. Next, coming to this, here net force is equal to 8 Newtons plus, what is net force? It is an algebraic sum of all the forces. Now we are going to add all the forces. 8 Newtons plus 8 Newtons. But as these two forces act in the opposite direction, one of the forces can be negative. Then what happen? 8 Newton plus into minus minus 8 Newton, then net force is equal to 0. Okay. Here two forces act in the same direction. When two forces act in the same direction, net force concept is what? Algebraic sum of all the forces. Now these two forces act in the same direction also. So what do we do? We will add the forces. The net force is equal to 14 Newtons towards right. Okay. Here net force is 0. That is why no direction. Here 9 Newtons of force act in upward direction, 8 Newtons of force act in downward direction. So what is the net force in this concept? Larger force minus smaller force. 9 Newtons plus minus 8 Newtons. So 9 Newtons minus 8 Newtons is equal to 1 Newton. 1 Newton towards up. So this way we have to calculate the net force. Net force is algebraic sum, and basic concept is when two forces act in the same direction in a line, okay, we have to take the sum of those two forces. Actually it is always sum only, but when two forces act in opposite direction, one of the force direction is taken negative, because force is a vector quantity, direction should be mentioned. So first vector direction is opposite to the second vector direction, or second vector direction is opposite to the first vector. So we cannot be done with a normal addition, vectorial addition should be done. So that is why compulsory should be taken negative only. That is why we get this way. Difference we have to find when two forces act in opposite direction. A man stands still. Still means rest. Still means rest on a level floor. What forces acting? Draw the free body diagram. A simple idea. This is the floor. A man is standing this way, right? Here simple idea. Gravitational force. One is gravitational force. Okay. And this here on the first leg is in contact with the floor. This floor exert a normal force upward direction. This leg also in contact with the floor. So here also another normal force. So the total normal force, resultant normal force, should be considered as only one normal force. Since both are acting in the same direction, the resultant of the N1 and N2 is taken as N, then only one normal force can be considered this way. Or also you can draw the free body diagram this way also. Gravitational force is downward direction, and two normal forces because of 2 feet, okay, of his body in contact with the floor. So we can draw this way also. But resultant of these two can be considered as one also. Okay. So this normal force is balanced by the gravitational force. Net force is 0. Okay. We have discussed many problems related to this free body diagram in a special video. Okay. Please go through this. How do you appreciate the role of friction in facilitating our activities? Role of friction. Okay. How friction help us to do various activities? Simple. Friction help us to open the cap. Friction help us to rotate the cap of the bottle, rotate the tap. Friction help us to open the cap of the bottle. Friction help us to lift the bag. Friction help us to write. There is a friction between this marker and my fingers whenever I write. There is a friction between your fingers and pen whenever you are writing on the board. Okay, when there is a friction between our feet and floor when we are walking. Okay, without friction can we walk? No, friction help us to walk. Friction help us to write. Friction help us to lift. Okay. Friction, for example, vehicles are moving on the road. When driver apply brakes, vehicle come to rest because of friction. If the friction, there is no friction between the tires of the road and tires, what happen? That vehicle move continuously and constantly until it hits. Yes or no? So friction, it is required to do many activities. In every activity, it is responsible. Okay, of course friction has both advantages and disadvantages that we discuss in the second chapter, because our second chapter is friction. In detail we discuss that. Okay, right. So this is the discussion of 4 questions. Okay, Here fourth question I haven't discussed, because fourth question is the problems already we have discussed in a separate video. That is why I haven't discussed fourth problem. Okay.